In Azure Blob Storage, lifecycle management plays a crucial role in helping organizations optimize costs, maintain regulatory compliance, and ensure efficient data maintenance. By automatically transitioning blobs to lower-cost access tiers or scheduling data for deletion, it reduces manual tasks and lessens the risk of retaining unnecessary data. This feature is especially valuable for organizations handling large volumes of data, such as logs, archival assets, or infrequently accessed backups. Lifecycle management is governed by defined rules that automatically orchestrate transitions across access tiers or apply retention-based deletions. These rules can be created or updated via the Azure portal, PowerShell, Azure CLI, or templates. When aligned correctly with business requirements, they help enforce cost-effective data storage strategies. Becoming familiar with these configurations is essential for Azure administrators who support data-intensive applications and require controlled, automated data oversight in their environments. Azure Blob Storage is a service designed for storing massive amounts of unstructured data. It supports various scenarios, from serving images or documents directly to web browsers to acting as a data repository for analytics or backup platforms. Blobs are hosted in containers within Azure storage accounts, each of which can employ different levels of redundancy, encryption, and network segmentation. By leveraging shared access signatures, SAS, and stored access policies, administrators can regulate granular permissions for external clients. BlobSoft Delete and ContainerSoft Delete guard against accidental data loss, while access tiers allow cost optimization based on usage patterns. Furthermore, Azure Storage Explorer and AZ-Copy offer convenient ways to manage data transfer and organization. Understanding these features is critical before applying lifecycle management, as effective lifecycle rules combine prior knowledge of security, tiering, and data organization strategies in Azure. Lifecycle policies in Azure Blob Storage generally fall into two categories: transition policies and deletion policies. Transition policies move data between access tiers, hot, cool, and archive, automatically based on custom criteria, such as last modification time. This ensures that infrequently accessed data migrates from the hot tier to the cool or archive tiers, reducing storage costs. Deletion policies specify when data objects are removed from storage altogether. Administrators can, for example, configure a rule to delete blobs older than a certain threshold. These policies help declutter storage, enforce retention guidelines, and conserve resources. Both policy types can be layered within a single lifecycle configuration to match comprehensive data governance plans. Typically, an organization will define multiple rules to handle different classes of data, ensuring that each data category follows its optimal cost and retention strategy, while meeting internal, legal, or regulatory obligations. Azure Blob Storage supports three main access tiers for block blobs: hot, cool, and archive. The hot tier is designed for frequently accessed data, while the cool tier is suitable for data not accessed as often but still needing occasional retrieval. The archive tier is the lowest cost tier, ideal for seldom accessed data requiring long-term retention. Transitioning between these tiers through lifecycle policies involves specifying rules that track the age or usage frequency of a blob. For example, you might set a rule that moves blobs to the cool tier after 30 days of inactivity, and then transitions them to the archive tier after 180 days. Below is a brief cost and access comparison. Tier access frequency retrieval costs: hot frequent low, cool infrequent medium, archive rare highest. Automated deletion policies form a central part of lifecycle management in Azure Blob Storage. These rules help ensure that data is only kept as long as it remains valuable or meets legal requirements. For instance, an organization might define a policy to delete log files 365 days after their last modification, freeing up space and minimizing unnecessary costs. By specifying a time to live (TTL) in the rule, blobs that surpass that criterion are automatically removed without administrator intervention. This automation fosters higher reliability and consistency in data oversight. Nevertheless, it is important to plan for potential compliance and auditing needs before implementing these rules. Typically, organizations combine automated deletion with retention features, such as timestamps or archive logs, to confirm that critical data is retained correctly. Proper planning and documentation ensure that these deletion policies remain aligned with broader data governance strategies. Designing an effective archival strategy is vital for large-scale data management in Azure. Lifecycle policies play a central role by migrating infrequently accessed blobs to the archive tier automatically. This approach significantly reduces storage costs, albeit at the expense of longer retrieval times for archive data. Some organizations pair archival transitions with specialized retrieval processes, ensuring that archive data is only rehydrated when explicitly requested by a business workflow or analytics job. Typically, multi-tier rules might move data from hot to cool after 30 days and from cool to archive after 180 days. However, administrators should consider compliance requirements, as archive data might still need to meet specific encryption or retention standards. Understanding the interplay between archiving schedules, retrieval patterns, and overall compliance ensures a well-structured data lifecycle that balances cost efficiency with operational needs. Azure Resource Manager, ARM, templates provide a JSON-based framework for provisioning Azure resources, including blob storage lifecycle policies. By embedding lifecycle rule definitions within the template, administrators maintain version-controlled, replicable configurations. This approach streamlines deployments to multiple environments, ensuring each environment adheres to the same governance model. Below is a simplified excerpt of an ARM template snippet, JSON type, Microsoft, storage/storage accounts, name, mistorage, API version, April 1st, 2021, properties, container delete retention policy, enabled, true, days, 30, delete retention policy, enabled, true, days, 30. This JSON structure can be extended to specify conditions for transitions between tiers and final deletions. Deploying an ARM template replaces manual portal configurations, reducing the chances of human error and promoting consistency across multiple Azure subscriptions. The Azure portal provides a graphical user interface for configuring lifecycle rules without requiring command line knowledge. To start, open the Storage Account resource and select the Lifecycle Management menu option. From there, create a new rule or edit an existing rule. Administrators specify conditions for transitioning data to lower access tiers or scheduling deletions based on the blob's last modification date. Multiple filters can be applied to target specific containers or blob prefixes, allowing selective management of data categories that share common naming structures. This level of granularity accommodates scenarios such as archiving only backup files while retaining frequently accessed images in the hot tier. Once the rule is defined, the portal displays a summary of its actions. Administrators can test the newly applied policy by reviewing the rules in the same pane, validating whether it aligns with cost management and retention objectives before finalizing the configuration. Azure PowerShell offers scriptable methods for managing lifecycle rules at scale. By using cmdlets, such as set as a storage account, administrators can toggle lifecycle settings programmatically. For example, PowerShell $context equals new AZ storage context, storage account name, mistorage, use connected account $rule equals new AZ storage lifecycle rule, rule name log cleaning, prefix match log slash, delete after days 30 city storage account, resource group name, myarg, name mistorage, lifecycle rule. This sample defines a rule named log cleaning that permanently deletes blobs residing in the log slash prefix 30 days after their creation. Administrators can combine multiple rules into a list object to handle transitions to the cool or archive tiers for different data objects. PowerShell scripting simplifies repetitive tasks, such as applying similar configurations to multiple storage accounts, while also enabling easy integration with continuous integration and deployment pipelines through automation scripts. Azure CLI is another powerful tool for configuring lifecycle management across different environments. By issuing commands in a terminal, administrators can define or update lifecycle rules using JSON files or command parameters. Here is a concise example. Bash AZ storage account management policy create / account name mistorage / resource group myrg / policy at policy.json. In this example, policy.json could contain the lifecycle rules specifying transitions and deletions. Alternatively, administrators can use AZ storage account management policy update to modify existing rules. This approach supports DevOps practices by encapsulating the lifecycle definitions within version-controlled text files. Similarly, it allows easy reproduction of settings across different subscription contexts, ensuring that development, staging, and production environments align with a consistent policy framework, reducing the risk of configuration drift. Implementing blob lifecycle management must align with broader governance and compliance standards. Some data sets, such as financial records or medical histories, fall under regulations that require specific retention periods or disclaimers before deletion. By crafting lifecycle rules that match these guidelines, Azure administrators ensure data is persisted or removed according to legal mandates. Furthermore, fine-grained controls, including those defining the scope of rules at the container or prefix level, help satisfy internal data classification requirements. For instance, distinct containers can be used for different categories of data, each regulated by unique policies. Integration with Azure Active Directory Role-Based Access Control, RBAC, and advanced logging options allows administrators to audit actions taken by the lifecycle engine. Ultimately, a well-planned governance framework combines policy definitions with robust monitoring, ensuring that compliance obligations are consistently enforced and independently verifiable. Once lifecycle management is activated, tracking performance and verifying correct rule application is fundamental. Azure provides metrics, activity logs, and diagnostic settings that help administrators detect policy misconfigurations or unexpected data transitions. For instance, if a blob is incorrectly moved to archive tier, analyzing logs can reveal potential misalignment of prefix filters or rule priority. Storage analytics logs track details about read and write operations, while Azure Monitor metrics highlight the status of transformation or deletion events. By combining these data points with Azure Monitor alerts, administrators can set up notifications for unusual events, such as a sudden spike in deletions or rehydration requests. Regularly reviewing these metrics not only preserves data integrity, but also supports cost forecasting, enabling better oversight of how lifecycle rules are impacting storage spend across different tiers or retention timelines. For successful lifecycle management, administrators should adopt a methodical approach. Begin by mapping business requirements to data categories, determining which datasets warrant routine transitions and which must remain in the hot tier. Next, ensure that naming conventions for container or blob prefixes reflect this classification, enabling precise targeting of lifecycle rules. It is advisable to test new policies on smaller datasets or staging environments before broad production rollout. This verification phase helps refine rule conditions or discover unanticipated edge cases. Additionally, incorporate queries for logs or metrics in standard operating procedures to confirm the policy's expected outcomes. Periodically revisiting lifecycle rules is also vital, as usage patterns or compliance obligations change over time. In sum, consistent reviews, thorough testing, and a structured design promote effective and reliable lifecycle implementations. Lifecycle management in Azure integrates seamlessly with various services. For instance, data pipeline processes in Azure Data Factory can offload or transform data before lifecycle policies archive or delete that content. Similarly, applications that store large volumes of media or IoT telemetry can benefit from automated transitions, ensuring that processed or outdated artifacts do not remain in expensive tiers. Some businesses connect lifecycle rules with event-driven workflows using Azure Event Grid or Logic apps. This allows triggers when data transitions occur, feeding downstream tasks like generating reports or updating metadata records. Meanwhile, teams using Azure Backup or Azure Site Recovery may coordinate retention settings to align with a broader disaster recovery plan. Such synergy underscores that blob lifecycle management is not an isolated feature, but a core component of an end-to-end data strategy, ultimately supporting efficiency throughout the Azure ecosystem.